Okay, the universal law of gravity. It states that any two bodies are attracting each other through gravitation with a force proportional to the product of their masses and inversely proportional to the square of the distance. So F equals negative g, which is the gravitational universal constant of gravity, and it's directly proportional, the force is directly proportional with the masses m1 and m2 over the radius squared between the both of those two bodies. So what does this mean? Let's understand the concepts of the physics of gravity. According to Newtonian gravity, when there are two bodies, any two bodies, there will be a gravitational force between them, attracting them to each other. And this gravitational force will be directly proportional with their masses and inversely proportional with the distance. So the farthest, the less the force of gravity, and the less the mass, the less the gravity. So the Earth is attracting the moon, and we will see why the moon is revolving around the Earth, and the Earth is attracting us. But does the Earth attract us only? No, we also attract the Earth, but the attraction is going towards the Earth because the Earth is more massive. It's more massive. No comparison, okay? It's very massive. We're very small compared to the Earth. Okay, the universal law of gravity allows us to understand orbital motion of planets. Okay, the Earth and Moon attract each other through gravitation. Since Earth is much more massive than the Moon's effect on Earth is small, but there is an effect. Like in the tides, when the Moon attracts the water, causing waves, high waves, when there is a full moon. Earth's gravitational force constantly accelerates the moon towards the Earth. This acceleration is constantly changing the moon direction of motion, holding it on its almost circular path. Okay, this is the Earth and this is the moon. It's having a velocity v, and this velocity is going in this direction, but due to the Earth massiveness, there is a force pulling the moon towards the Earth, causing it to accelerate, changing its velocity. It changed the acceleration, causing it to rotate, to change from this direction to this direction, and it keeps revolving. Okay, so there is a speed that if you have a cannon and the initial velocity that you threw this boom from the cannon on that ball from that cannon, if it's very fast, it will just leave the Earth and go away. But if this speed was not enough, this body will be attracted to the Earth, and if it's more, it will be just attracted again. But there is an escape velocity where it can leave the Earth. and at a certain velocity and speed, that body can revolve around the Earth and just return to the same point again and keep revolving. Okay, what are geosynchronous orbits? There are satellites that revolve around the Earth in 24 hours. There is an orbital radius that at this orbital radius the satellites start to rotate around the Earth in 24 hours, which is at a distance of 42,250 kilometers from Earth's center. A satellite orbits with a period of 24 hours. So what does this mean? This means that the Earth is rotating with the same speed of the Earth. The satellite and the Earth rotating together, which means the satellites will be synchronized and in connection with the same spots. So when you observe it from the Earth, you will watch it like it's standing still, like it's not moving, because it's moving with the Earth rotation. And these kinds of satellites, they are used to emit radio wave, emit electromagnetic waves that are used in cables and so on for TV. Kepler's third law. It's the law that we just said that at a certain distance there will be a certain velocity. So Kepler's law organizes the relation between two bodies revolving, like a planet revolving around the sun, a satellite revolving around the Earth. So balancing the force called centripetal force necessary to keep an object in circular motion with a gravitational force, expression equivalent to Kepler's third law. So the periods squared in years equals the distance between the both centers, the body revolving around the other, cubed, and the distance is in astronomical unit, knowing that the astronomical unit is 100 million kilometers, and it's the distance between the Earth and the Sun.